Alright, boys and girls, welcome back to the drive-thru for a remix! We're going to get the video right this time because I screwed up the projection from U onto V last time, so let's get going. Alright, we're back into vectors now. You learned vectors in Algebra 2. If you remember, what's the point of vectors? Well, a vector is a two-dimensional ray, so maybe this one is like over 8 and up 7, okay? It can be written as 8, 7. You also, sometimes in physics, write it as 8i plus 7j. That's another way to write it. And they represent direction and magnitude, okay? So what's the magnitude of this thing? The magnitude is how long it is, which is the square root of 8 squared, 64, plus 7 squared, 49. Oh God, what is that? Is that 113? Yes, it is. So, if we call this U, then the magnitude of U is the square root of 113. The direction is right 8 up 7. What is this used to represent? Well, really important things like velocity or acceleration or force. All of these things are aspects of physics, aspects of motion that have both size and direction, magnitude and direction. Okay? You've learned that before. Now, what is a dot product? A dot product is like a compatibility test. Okay? If we've got a vector U and a vector V, and the angle between them, remember that vectors have no position, so you can place them anywhere you want. It's often very convenient for you to put them so that their initial point is in the same spot. If the angle between the vectors is obtuse, then U dot V is negative. Okay? If the measurement between the vectors is a right angle, then U dot V will equal 0. And if the angle between the vectors is acute, then U dot V equals positive. So what do I mean by a compatibility test? Well, sometimes opposites attract. So if U dot V is negative, these people have direction in common, but they're actually headed in the complete opposite direction. But you'd be surprised like how parallel this is. If you are like completely on the right and someone else is completely on the left, you actually have a lot in common. You just don't have the same beliefs in common. But the structure of your belief system is actually very close. Whereas like these people have nothing in common. This person is a hard right, and this person is completely centrist. They may not even have an opinion. These people would have a hard time communicating. They literally have nothing in common. These people wouldn't enjoy their communication, but they actually have a lot in common. They just disagree. Whereas these people both share the same view and have things in common. Okay? So, that's what the dot product represents. It tells us nothing else, but it's very useful in finding some things. One of the things that we'll use the dot product to do is to find the angle between vectors. We use cosine to do this. Let me get this turned on. We're going to need it here in a second. The cosine of the angle between the vectors, U and V, is equal to U dot V over the magnitude of u, the size of u, times the magnitude of v. Okay? Come on now. Here we go. Here we go. So, let's start by proving something. Let's say we want to do the vector 10, 0 and 0, 4. Okay, so we would say the cosine of theta is u dot v. Oh, did I tell you how to do a dot product? I didn't. So let's tell you how to do a dot product. Let's just do an example. It's very simple. If you have 1, 3 dot 6, negative 5, okay, you do 1 times 6 plus 3 times negative 5, 6 minus 15. The dot product is negative 9. Well, that means that these vectors, if you put them from the same starting spot, will be obtuse. So now I'm ready to go back to this example. Okay, let's find the dot product of u dot v. So it's 0 times 10 plus 4 times 0 over the magnitude of u, which is 4 units, times the magnitude of v, which is 10 units. You get cosine of theta is 0 over 40. Take the cosine inverse of both sides, and you get theta is, you know the answer, but I'll show you, second cosine 0 divided by 40. I'll even divide it by 40 in case you don't even know what that is. Uh-oh. All right, we're in radians. All right? No, that shouldn't matter. Cosine inverse of 0. Let me pause the video real quick. Duh. That would be pi over 2. Let me make this more sense by going to mode. Let's get into degrees. I know you guys are more comfortable working with degrees. Eventually you'll be comfortable working with both. And let's go back. And let's do it again. So you get 90. This right here is pi over 2. This is 90 degrees. Those two things are the same thing. So that's good. We just proved, okay, we just proved that if the dot product between something is 0, then the angle is 90 degrees, okay? Let's do another example. Let's do an obtuse example. So let's go maybe that one and this one. That looks obtuse to me. This is u, this is v. U looks like, let's see, 1, 2, 3, 1, 2, 3, 4, 5. So u is negative 3, 5, and v is 10, 1. Okay, so if you wanted to find the angle between those two vectors, cosine of theta is negative 3, 5 dot 10, 1 over, let's see, radical 9 plus 25, 36 times radical 100 plus 1. Okay, so cosine theta is, that's a negative 3. Negative 3 times 10 is negative 30. 5 times 1 is 5. I swear I wrote a 5. Over radical 36 times radical 101. So take the cosine inverse of each side to find theta. You do second cosine, parentheses, negative 30 plus 5. I hope you guys don't need to type that in your calculator. divided by, oh, hold on. I need two sets of parentheses here. Negative 30 plus 5 divided by, parentheses, radical 36 times radical, delete, radical 36 times, you could have just kept both numbers under there, radical 101 over, close it again, enter, bam, and you get theta is 114.5 degrees, about that. Well, good, that makes sense to me. Let's do one more example, but we'll do it on the next shape. Okay? Let's do an acute. Alright, so we have the vector 1, 2, 3, 4, 5, 6, 6i plus 2j, that's the same thing as 6 comma 2. We have the vector 3i plus 1, 2, 3, 4, 5, 6, 6j, that's the same thing as 3 comma 6. Oh boy. Let's just put it right back up here and get it out of the way of our, okay? Bummer. Alright, we're going with it. 3, 6. Alright, so cosine theta is equal to, now let's do the dot product in our head. 18 plus 12, 18 plus 12, 30 over, this one is radical 9 plus 36 times radical 36 plus 4. So, once again, we got to do cosine inverse. Let me make this easier for you this time. Second, cosine 30 divided by, I really can just put both things in the square root on the bottom. 45 times 40. Close it. Nope, it's not what I wanted. Delete. Close it. Uh-oh. They didn't like that notation. Alright, let's see. Second cosine. Parentheses. Parentheses. Oh, jeez, oh, Pete's. Parentheses. 30 divided by this should not be this hard. 30 divided by parentheses, maybe they want 45 times 40 on the bottom, close it. Close it again. Does it like that? There we go. Really, 89.0. Oh, I didn't do the radical on the bottom. Second, cosine 30 divided by radical. Why won't it take the radical? All right. Does that work? I think we just tried that before. No way. That's a 45-degree angle between those two? That's really good. How did I come up with that? It looks like a 45-degree angle to me. I could use right triangle trig to explain that to you guys, but you could do that on your own. Let's continue on. All right. finding the projection of one vector onto another. Let me start by just explaining to you what this looks like. If you had some vector here, okay, and then you had another vector like this, and let's see, this one would be U and this one would be V. Now let's say we had a flashlight that was shining from above. And it's shining light from above. Can you imagine what shadow this red vector would put on the blue vector? It would look like that. This blue vector is the projection of U onto V. That's the notation. And you find it by doing U dot V over the magnitude of V squared. Now, this is basically saying how much of U is going in the direction of V, and then it's normalizing it by dividing it by the size of V. Okay? You're going to take that and you're going to multiply it by the vector V. So this thing is a scalar. A scalar is just a number. This is a scalar. This is a vector. And when you take a number times a vector, the answer is a vector, which is what we wanted. We wanted to get this blue vector right there. So let me show you how to do it. Let's say that the black vector V is 10, 0. And let's say that the red vector U is, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say it's 5, 10, even though ours is a little off, but you still get the visual. All right, so it's U dot V. So the projection of U onto V is U dot V, which is 50, over the magnitude of V squared, which is 100, times V, 10.0, 10, 0. So it's 1/2 of that. It's 5, 0. Beautiful. That's exactly what it looks like it is. So that is how much of vector U is in line with vector V. How much of U is going in the direction of V. In physics, that's going to be it's going to be a very important use. Okay? All right. I hope this helps. Kind of a long video. I apologize. Boom!